Alright, in today's video, we are going to talk about the volume of solid revolution when the curve revolves about the x-axis and about the y-axis. Take note that this subtopic will not be asked in IGCSE examination, but will be asked in SPM. So just take note about that. Okay, let's have a look on the first slide. Okay, volume of solid revolution when a curve revolves about the x-axis and about the y-axis. Suppose that I have this picture here, okay, and we can see that there is an area that, okay, if you want to find the volume of the area, obviously it's just area is just equals to integration from a to b of the function y with respect to x. Y with respect to x because the boundaries we're on the x-axis. Okay, so just imagine if we turn this area about the x-axis, turn that. So if we turn this area, we will sort of like produce a bowl, maybe a bowl. Okay, so if I draw the bowl, it will look something like this. Okay. So we can actually find the volume for this bowl by using the formula Vx is equals to integration from a to b of pi times with y squared Vx. Right. With respect to x, which means that we will turn about the x-axis, and we will have the what do you call it? The boundaries on the x-axis. So just insert the formula, insert the value into this formula, and we will get the volume of the bowl, the solid that we produce when we turn the area about the x-axis. Now, what happens if we turn the area here about the y-axis? Okay, it's the same thing. We will get something that will look like a bowl as well. Okay, an open bowl, something like this. So we want to find the volume of this. Since it turns about the y-axis, okay, it turns about the y-axis, the formula that we are going to use is Vy is just equals to integration from a to b of pi times with x squared dy. We must make sure that if we turn about the y-axis, then the boundaries has to be on the y-axis and with respect to y. So we are going to have a look at examples on how to apply this formula. Okay, let's have a look at this example here. Okay, example, calculate the volume of the solid generated when the shaded region in the diagram is revolved through 360 degrees about the x-axis. So we have this diagram here. It will be revolved 360 degrees about the x-axis, means that we are going to turn about this x-axis. So we are going to produce something that looks like this. Okay, we need to find the volume of this solid. So we sort of like we will get something that looks like that. So we want to find the volume of this solid. So we can apply the formula Vx equals to integration from a to b pi of y squared Vx. Okay, do we have the boundaries? Yes, we do have the boundaries, which is 1 until 4. So this is just equals to integration from 1 until 4 of pi y squared dx. Now do we have y squared? Look at the formula. It's given to us y. So what we need to do is we need to find y squared. How do we find that? Okay, given that y is equals to x plus 2 over x, which means that y squared is just equals to x plus 2 over x squared. And here I would like to use the formula a plus b squared will produce a squared plus 2ab plus b squared. So in a sense that we will get a squared is just x squared plus 2 times with x times with 2 over x plus with 2 over x squared. So simplify things, we will get x squared plus 4, since we can cancel out x, and plus with 2 squared is just 4, x squared is just x squared. So now this is our y squared. Okay, you can see our y squared here. Y squared is just equals that. So what we need to substitute into this y squared, right? So we will get everything in terms of x. We get integration from 1 until 4 of pi times with x squared plus 4 over x squared with respect to x. And pi is just a constant. We can bring it outside. So we will get pi times with integration from 1 to 4 of x squared plus 4 x power of negative 2 with respect to x. Okay? So now we'll start the integration process. So we will get x power of 3 over 3 plus 4x plus 4x power of negative 2 plus 1 over negative 2 plus 1. And the boundaries should be 1 until 4, 1 until 4. So we should get pi times with x power of 3 over 3 plus 4x plus with 4x power of negative 1 over negative 1. Boundaries 1 until 4. So pi x power of 3 over 3 plus 4x plus with, minus with 4 over x for 1. Okay. So now what we need to do here, remember top minus bottom. So we just substitute the value. So we will get 4 to the power of 3 over 3 plus 4 times 4 minus 4 over 4 minus with 1 to the power of 3 over 3 plus 4 times 1 minus 4 over 1. So what you need to do here is you need to just press your calculator. You should get 109 over 3 minus with 1 over 3. So this is just, we will get pi times with 108 over 3. So 108 over 3 is just equals to 36. So we will get pi 36, which is just 36 pi units power of 3, since this is volume. So that is the final answer for the question. Okay. Now let's have a look if we have example of volume revolve through 360 degrees about the y-axis. So we want to find the volume when the diagram is revolved through 360 degrees about the y-axis. So for example, we have this diagram here. Just imagine if this area is turned about 360 degrees about the y-axis, so we will produce a solid that looks something like this. We want to find the volume of this solid. And we turn about y-axis, which means that we need to use Vy. Vy is just equals to integration from a to b pi x squared dy. Okay, so again, dy. dy means turn about the y-axis, so the boundaries should be on the y-axis. So we know that the boundary starts from 0 until the top here. How do we find the top? At this top here, we know that the coordinate of 0, coordinate of x is 0. We need to find the coordinate of y. So we substitute into the equation, this equation. So y equals to 7 minus x squared. Since x equals to 0, so we have 7 minus 0 squared is just equals to 7. So the top here is just equals to 7, which means that the coordinate here is just 0, 7. But the most important, we know that from here to here is 0 to 7. So substitute that value to the equation from 0 until 7 of pi x squared dy. Now we need to change x squared in terms of y. So we have y equals to 7 minus x squared. Move that term to the left hand side and y to the right hand side. We should get x squared equals to 7 minus y. Now we have our x squared in terms of y. Just substitute that into x squared there. Okay, so this is just equals to integration from 0 until 7 of pi times with 7 minus y with respect to y, and pi as a constant, we can bring it outside. So it becomes pi times with integration of 0 until 7, 7 minus y with respect to y. Now we do the integration process. So pi equals to 7y minus y squared over 2, y squared over 2. This is a normal integration from 0 until 7. Okay, now you substitute the value. Pi times with 7 times 7 minus 7 squared over 2 minus with, so top settle, bottom 0. So if we substitute 0 into the both terms, we will get 0. So it's just minus 0. So we should get pi times with 749 minus 49 over 2 minus 0 is just equals to 24.5 pi units to the power of 3 since it's volume. So that is your final answer for this question. Okay. Okay, now let's just go through to the last example. So the diagram shows part of the curve. We have a curve y equals to 1 minus x squared and a straight line, which is 5x plus 3y equals to 15. Find the volume generated when the shaded region is revolved through 360 degrees about the y-axis. So just imagine the shaded region, it's revolved 360 degrees about the y-axis. So somehow we will produce a cone. Just imagine a cone. Okay. So this cone will have a hole in the middle. Okay. So we want to find the volume of the cone minus the hole in the middle. Okay. So again, how do we do this? How do we find the volume of that cone with a hole in the middle? Okay. What we can do is first we find the volume of the cone as a whole. Now we minus with the volume of the hole in the middle. So we find the volume of the whole cone minus with the volume of the solid in the middle, then we will get the volume of the cone with the hole in the middle. Okay, to find the volume of the cone, which means that we need to find this area here, the total area here, and we will just turn about the y-axis. So since we turn about the y-axis, means that we need to use the formula Vy equals to integration from a to b pi x squared dy. Do we have a to b? So we know that our a is 0. What is our b here? Okay, we want to find this b here. So the point B lies on the straight line. So at the point B, coordinate of x is just equals to 0. Substitute x equals to 0 into this equation. We will rearrange and get the corresponding coordinate of y. So 5x plus 3y equals to 15. At B, x is equals to 0. Therefore, we have 5 times 0 plus 3y equals to 15. 3y is just equals to 15. Y is just equals to 15 divided by 3. Therefore, y is just equals to 5. Which means that coordinate of B is just equals to 0, 5. Which means that the height here is 5. Okay. So we have A and B. Now we need to find for x squared. The formula given is 5x plus 3y equals to 15. So 5x equals to 15 minus 3y. X equals to 15 minus 3y over 5. Okay. So we want to find x squared. In this case, I would like to divide into two terms. So it becomes 15 divided by 5 minus 3y divided by 5. So we should get 3 minus 3y divided by 5. Okay, but we don't want x, we want x squared. Means that we need to square 3 minus 3y over 5 to the power of 2. So again, if I have quadratic expansion, I would like to use the formula. You can just expand it like you usually do. There's many methods that can be used to expand brackets. But in this case, for me, I like to use the formula. If we have a minus b squared, we should get a squared minus 2ab plus with b squared. So which means that I should get 3 squared minus 2 times 3 times with 3y over 5 plus with 3y over 5 squared. Okay. So simplify things, I will get 9 minus with 18y over 5 plus with 9y squared over 25. So now we have our x squared. What we'll need to do is to substitute into that formula. Okay. So basically, this is just integration from 0 until 5 because we want to find that, okay, the area and revolve around the y-axis. Okay, we want to find this area here, okay, and it's revolve around the y-axis. So we use the boundary from 0 until 5 of pi. We find our x squared just now. Our x squared is just equals to that, okay, with respect to y. And again, pi is just a constant. We can bring it outside. So it becomes pi times with 0, duration from 0 until 5 of the equation with respect to y. Now we do our normal integration. So pi times with 9y minus with 18 over 5 y squared over 2 plus with 9 over 25 y to the power of 3 over 3. Okay, and our boundaries is from 0 until 5. So you can simplify if you want to. If you don't want to, then you can just insert the value here and produce the answer. So I think I don't want to simplify, so I will directly insert the value. So we have 9y, instead 9 times 5 minus with 18 over 5 times with 5 squared over 2 plus with 9 over 25 times with 5 to the power of 3 over 3 minus with, if you look at the whole thing, every terms we have y. Okay, so if we insert 0 in each term, we will get a 0 because anything multiplied with 0 will produce 0. So eventually, if you insert 0, you will still get 0. Okay, for down here. So we settle with 5, we settle with 0. So when you press your calculator, you should get pi times with 15 minus 0, so which is just equals to 15 pi. Now we have the volume of our cone. The next one, we need to find the volume of our hole in the middle. Okay. So for the volume of our hole in the middle, let's have a look at the diagram there. Okay. So our aim is to find the area here and turn it about the x-axis. So we could produce, turn it about the y-axis, so we could produce a solid that looks like that one. So what we have here, we need to find the boundaries. So from 0 until the top here. Okay, the top here. How do we find the coordinate for that one? Again, at this top, the value of x is equals to 0. We need to find the value of y. Okay. Since given the formula is this formula there, so at x equals to 0, y is just equals to 1 minus 0 squared is just equals to 1. So the coordinate is 0, 1. Means that the height here is just 1. So if I draw here, Okay, sorry. See, if I draw here, this is from 0 until top here 1. So again, if you want to find the volume, we can use turning around the y-axis, about the y-axis. So we use the formula Vy equals to pi, sorry, integration from a to b of pi x squared dy. Now, do we have our x squared? Okay, the formula for the curve is y equals to 1 minus x squared. For the curve, the formula is y equals to 1 minus x squared. Bring right hand side to the left hand side, we should get, and right hand side to the left hand side, we should get x squared is just equals to 1 minus y. Substitute that into the equation. So in a sense that we have integration from 0 until 1 of pi times with 1 minus y with respect to y. Okay, so pi is a constant, we can bring it outside, becomes pi times with integration from 0 until 1 of the function 1 minus y with respect to y. Okay, now we do the normal integration, we should get pi times with integration of 1 is just y, and then we have y squared over 2, 1 until 0. So substitute the value, pi, so 1 minus 1 over 2, so settle with that one, and second part becomes 0 minus 0 squared over 2, so equals to pi, it's just 1 over 2 minus with 0. Take note that you can skip this step because we know when we insert 0 into each term, we will still get 0. Okay, so it's just 1 minus 1 over 1 squared over 2 minus 0 is equals to pi times with 1 over 2. So it's just equals to 1 over 2 pi. So that is the volume for the solid in the middle. Okay. So to find the volume of the solid generated with a hole in the middle, it's just 15 pi minus with half pi. So this is just 15 pi minus with 1 over 2 pi. This is just equals to 14, 1 over 2 pi, or 14.5 units to the power of 3. Okay. Some of you might think, why do we need to use the word units? Because it is not given that the height or the length of the cone is in centimeter or in meters. So if it's not given any units, we just call it as units. And why is it to the power of 3? Because this is volume. Okay. Okay, I think that's all for today. So we have completed the whole 7 major subtopic of the chapter integration. In my next class or in my next video, I will talk about, we will have a look on a few examples of the real examination IGCSE paper um, involving chapter differentiation and integration, and the mix of both chapters. So I hope you understand today's lesson. I'll see you soon. Bye bye.